Hello everyone, my name is Meenakshi Rameshwar Bhagat and today we are going to talk about the one of the fundamental data structure, circular doubly linked list. If you are a new to programming or like you are a student, just you someone interested in data structure, do not worry. I will bring you everything about the simple terms. By the end of this video, you will know about what is the circular double linked list and where is different from the other linked list and where you can apply it. So let's get started. What is linked list? First, let's talk about the basic. A linked list is a linear data structure where which node is connected to the next node using a pointer. Each node contains data and the address of the next node. It is used in many programming applications to overcome the limitation of array such as their static size. In a simple linked list, the last node pointer to the null and making the end of the last. What is the circular doubly linked list? Now let's move on our topic, circular doubly linked list. A circular doubly linked list is an advanced types of linked list where which node points us to both the previous and next node, making the list doubly linked list. What's making it the circular is that the points us back to the first node and first node pointer to the last node, creating a loop. In each circular doubly linked list, each node has a three component: first, data; second, a pointer to the next node; third, the pointer to the previous node. The difference here is that the last node does not point to the null like a single linked list. Instead, the last node like a back of the first node and first node previous pointer points to the last node, that make it the list circular. Previously we see what is the linked list. Linked list is a linear data structure where each element called the node is connected to the next one in the sequence. Each node in the linked list consists of the two constants. First one is the data, which hold the actual value, and second one is the next, which is the pointer or reference of the next node in the sequence. In a typical way, we have a head, which is the started point, and each node connected to the list end when the node point of the null, including the last node in the list. This is the difference from the array where elements are stored in the memory block. Like linked lists are more flexible since the node can be scattered throughout the memory and or only linked through their pointers. We will break down this diagram. What is the head? Head is the starting point of the special node called as the head, and this is the first element in the linked list, and this is the entry point of the access of entire file. If there are no nodes in the head itself, only the null. Second one is the data. Each node holds the actual value or actual data we have to store and process. This can be any data. This can be any data types or image, files, or more complex data also. Third part of the next pointer. The second part of the node is the next part, which consists the address or reference of the next node is in the sequence. Fourth one is the null. Last node next pointer points to the null, including the endpoint of the list. This is an important mark because it is to tell us that we are not more after this point. The summary is the each data section consists the actual information and the next pointer connected to the next node in the sequence. The last node next pointer points to the null, including the next point of the list. Previously see what is the circular doubly linked list. Circular doubly linked list is the complex data structure where each node has the three main parts. First one is the data, second one is the next, third one is the previous. Data is the hold the actual information or actual value. Second, next, the pointer is the next node of the list. Third one is the previous, the pointer of the previous node in the list. Unlike a regular linked list, in a circular doubly linked list, the last node of the point back to the first node and first node of the point to the last node, creating the circular connection. As you see in this diagram, each node each node linked together in this next node and previous nodes. If you start any point, you can move forward or backward to the list, and if you are keep going, you will eventually circle back to the same node you can start with. The list starts with the head, which points the first node. Each node consists of first one is the data part, which store the information. Second one is the next pointer linked to the next node, and third one is the previous pointer linking to the back of the previous node. And tail is the last node, which lies in back of the head, completing the circle. This makes it easy to travel in both directions from the any point of the list. Now we will see the application. So where can we use or apply the circular doubly linked list? Polynomial representation. Circular doubly linked list help represent the complex mathematical explanation like polynomial. Second one is the stack matrix. In a memory optimization, stack matrix can be a efficiently representation using a linked list. Stack, queue, and tree linked lists are used in verified data structure, and including the stack and queue and tree are also a circular doubly linked list. Now next one is the operation of circular doubly linked list. Next, let's go over the queue operation you can perform on a circular doubly linked list. There have a 5 operation. First one is the insertion, second one is the deletion, third one is the display, fourth one is the search, fifth one is the traversal. Let's see the first. Insertion is adding the new node either the beginning, end, or between it. And second one is the deletion. Deletion is the removing of node or deleting a specific node or first node or last node also by updating the adjacent node or point. Third one is the display. Print all nodes value by looping through the list. Fourth one is the search. Look for the node with a special value by the traversing at the list. And traversal. Move forward using a next pointer or backward using a previous pointer. In this operation make the circular doubly linked list flexible. Now we will see advantages of circular doubly linked list. The dynamic data structure can be a grow and shrink of the runtime, allowing the flexible memory uses as a node can be added or removed without the resigning array. Efficient insertion and deletion. Insertion or deletion of a node is fast, especially at a beginning or end, because pointers are easily adjusted without the sorting element like the array. Implementation. Circular doubly linked list allow the same forward and backward traversal, making it useful for applications like navigation system, music playlist. Disadvantages of circular doubly linked list. Increase the memory. Each node has a 2 pointer consisting more memory than a single linked list. Complex implementation. More complex to implement due to the managing both next or previous pointers. More pointer adjustment, requiring the uploading both pointers during insertion or deletion, adding a complexity. Overhead in traversing the large list may require the extra logic to avoid the endless cycle, impacting performance. Thank you for watching.